All right, so far we've looked at binary compounds and how to name them. You've learned to name type 1, type 2, and type 3. Type 1 being with a metal, true metal, and a non-metal. Type 2 being a transition metal and a non-metal. And type 3 being two non-metals. So everything we've done before has been binary. So when we've asked ourselves, is it binary? We said yes. And this says to look at figure 2.23, but we know this is in chapter 5 for us. So you would go to that flow chart that tells you how to name type 1, type 2, and type 3. So what happens if we come across the question again and say, is it a binary compound? And the answer is no. What are we looking for? Well, we have to start looking for a polyatomic ion or ions to see if they're present in the compound. If the answer is no, we cannot identify a polyatomic ion or ions in the compound, then you haven't been taught to name that yet. However, if you can identify polyatomic ions, then you're going to name the compound using procedures similar to those for naming your binary ionic compounds. Just a few things are going to change. Polyatomic ions, by definition, are ions with more than one type of atom. Polyatomic ions that are anions, so they have a negative charge and have oxygen in them, we refer to those as oxyanions. Can polyatomic ions be cations? Can they have a positive charge? The answer is yes. Here's an example. It's called the ammonium ion. So it's 1 nitrogen, 4 hydrogen, and it has an overall charge. This entire thing right here has an overall charge of +1. Polyatomic ions behave like a single atomic ion and always have set charges. So just like our true metals, we always know what their charge is. We always know the charges on polyatomic ions. And they behave like a single atom. So here's a table of common polyatomic ions that are found in your textbook in chapter 5. It's not 4, but chapter 5. So as we look at these, you'll notice that there's one cation, which is ammonium. Then we have all the others that are negative. Now, a couple things I want to bring out is that this is not a complete all-inclusive chart. As we go through, I'll tell you some others you can write down. I have a table for you that has polyatomic ions on it that you can use as one of your magic sheets that go along with your periodic table. What I want you to understand is that NO2 acts like a single element, but it behaves as a single element and it goes together as one group. And it has an overall charge of -1. NO3 has an overall charge of -1. I know what you're going to do is you're going to look at it and say, wait a minute, let me figure out how many electrons and see if this has a negative charge or it should have a positive, or I don't understand, this doesn't balance out. How can NO2 be negative and NO3 also be a -1? Remember, these are sharing bonds here. So they're covalent bonds. So when you put those together, it comes up with a charge due to sharing. So you don't have to memorize the chart that I'm going to give you or this table, but as you go through, you'll be more and more familiar with these polyatomic ions, and then we're going to learn how to name them correctly. So here's the rules. First of all, you have to recognize you have a polyatomic ion. That's the whole key to it. Once you recognize that, you have to go back to the type 1 and 2 naming rules. But we're going to use polyatomic ion names instead. Okay, so the best thing that we can do is do a few of these together and see if you can't kind of get the hang of it. To do that, I'm going to go back to the polyatomic ion chart that we had before. There it is. And we're going to look at this compound that's up here. So the first thing that we have to ask ourselves is it a binary compound? Are there only 2 types of elements? The correct answer is no. So the next thing I have to do is look for a polyatomic ion. When I look at this compound, I see right away that I'm dealing with sodium here. So sodium is Na subscript 2. So now I'm going to look at that separately from this, and I look at this and say, okay, I know I've never seen that before. Let me see if it's on the polyatomic ion chart. So I come over here and I look for SO4, and there is an SO4. So SO4 minus 2. So what I'm going to do to name this is a true metal, and we always know the charge on a polyatomic, so I'm going to name it like a type 1 because it's a true metal and an anion. And I'm going to name it just like I did before. I'm going to say sodium. And then I'm going to name the second one, and I'm going to use sulfate. Now here's a big difference. Notice that this ends in 8, we are not going to change the endings on the polyatomic ions in this case. So we don't change them to I. That was only if there was a single element. With it being a polyatomic ion, we leave the endings just like they appear on the polyatomic ion chart. So the correct name for this compound is sodium sulfate. Take a look at another one. Let's try this compound. So we look at it, and the first question we ask ourselves is it binary? The answer is no, it's not. So I have to look at it and say, does it have a polyatomic ion in it? Well, I always start here at the first and see what I'm dealing with, because the only cation that I really am familiar with is the ammonium ion. So chances are, if there's a polyatomic ion, this first one's probably going to be a metal. So I look at it, is that a metal? Yeah, I know it is. It's iron. But I also know that iron is a transition metal. So I'm going to have to make sure that I put my charge on iron here in parentheses. Now I look for OH. So I go down through here. Do I have an OH? Oh, here it is, OH. It is named hydroxide. So I'm going to name it just like it says. I'm not going to change the ending. And notice this one has an ending of hydroxide as "ide" already. We leave it like that. Now what I'm going to have to do is figure out what my charge is on my iron. Well, each hydroxide, just like we could look at the periodic table and look at the group that chlorine's in and say they always have a -1 charge, hydroxide is always going to have a -1 charge. So I have a -1 charge. How many hydroxides do I have? I have 2. That means that this side is a -2 charge. If this portion is -2, that means that this portion has to be +2. I have 1 iron atom. So what must the charge be on iron in order for this side to be a negative or a +2 to balance our -2? It must be a +2 charge. So this is going to be named iron 2 hydroxide. So the big obstacle that you have is to look at it and determine if it is binary or not. And after you determine that it's not binary, then you have to go through and you have to find out if it has a polyatomic ion in it. And those we're going to look at today will. And you're going to have to look at those and learn how to name them. Just remember not to change the endings when we name them like this. So let's practice on some in class.